Ever wondered what unit testing is and how it works? Well, let's unravel this mystery together. At its core, unit testing is a method where individual parts of a code are tested to determine their fitness for use. Imagine it as a quality check for the smallest yet crucial parts of a software. Think of a software as a puzzle. Each piece, or unit, plays a significant role. These units are usually the smallest testable part of any software. They might have one or a few inputs, but usually a single output. The goal is to verify that each of these units function as intended. This method of testing is akin to ensuring each piece of the puzzle fits perfectly, even before attempting to put the entire picture together. It's all about validating the functionality of each independent software component. So now you understand the basic concept of unit testing, let's delve deeper into the process. Now that we know what unit testing is, how do we do it? Let's delve into the process, which, while intricate, is essential in ensuring the quality of our software. The first step in unit testing is identifying the units. A unit here refers to the smallest testable part of any software. It could be a method, a procedure, or a function, depending on the programming language at hand. The key is to isolate these units to test them independently from the rest of the code. This isolation helps us pinpoint any issues directly to the source instead of sifting through layers of interwoven code. Next, we venture into the realm of writing test scripts. In simple terms, a test script is a set of instructions that is executed to verify if a unit of code functions as intended. It's a bit like a detective story where the tester plays a sleuth, predicting the outcomes and documenting them meticulously. Once the scripts are written, it's time for action. The tester executes these scripts to test the code. The primary aim here is to confirm that the output of the unit under test matches the expected result. If it does, it's time to break out the confetti. But if it doesn't, it's not the end of the world. It's just a sign that there's room for improvement. This brings us to the next step. If the test fails, the software engineers need to modify the code. This could mean fixing a bug, tweaking an algorithm, or even rewriting chunks of code. The important thing is to ensure the unit works as intended. Once the code is modified, the unit test is run again. This cycle of testing, fixing, and retesting continues until the unit passes the test. It's a bit like practicing for a play. The cast rehearses, identifies the weak points, and then fine-tunes their performance until it's perfect. And that's how the process of unit testing works. It's a cycle of testing, fixing, and retesting until everything works perfectly. It may seem like a lot of work, but in the grand scheme of things, it's a small price to pay for the peace of mind it brings. So, when do we use unit testing and who's responsible for it? Let's delve into that, shall we? Unit testing is generally conducted during the development phase of the software cycle. Why so early, you ask? Well, it's simple. The sooner we catch and rectify bugs, the better. It's all about nipping problems in the bud and ensuring the software runs as smoothly as a hot knife through butter. Now, who gets to play detective and hunt down these bugs? More often than not, it's the software developers themselves. They know the code like the back of their hands and can often spot issues quickly. However, in some cases, there may be dedicated software testers. These are experts whose sole mission is to find and exterminate bugs, ensuring the software functions flawlessly. Remember, unit testing is crucial during the development phase and is typically handled by the developers or testers. Lastly, let's talk about the tools that help us in unit testing. There's a wide array of tools out there designed to make unit testing a breeze. Let's delve into a few popular ones, starting with Junit, a simple yet powerful testing framework used for Java programming. It provides annotations to identify test methods and gives assert methods for testing expected results. Next up, we have Nunit, a unit testing framework for all .NET languages. It serves the same purpose as Junit, but is tailored for the .NET environment. Lastly, we can't forget PHPUnit, the de facto standard for unit testing in PHP. It offers both a framework that makes the writing of tests easy, as well as the functionality to easily run the tests and analyze their results. These tools simplify the process of unit testing by providing a structured framework and straightforward methods to test the code. So, with the right tools and understanding, unit testing can become a smooth and efficient process.